sign, subtract. Keep the sign of the higher number, then it'll be exact.
Whoa, 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 who's our guest singer tonight? Some of our choir students are going to have to teach him how to hit those notes. Hello, the purpose of today's video is to be able to add rational numbers. In a previous video, we learned how to add integers. And today, we're going to add more rational numbers, decimals, and fractions. The rules that we talked about in our previous video are going to apply to the rules in this video as well. So if you heard him singing, he said, same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact. Let's see what he means by this. Same signs add and keep. Well, this problem, I do have the same signs. They're both negative. So I'm going to want to add them together. Remember from our previous video, if the signs were alike, we add. So let's do that first. From 6th grade, you should remember when adding decimals, you line the decimals up. So we have 5 and 600ths and 2 and 4/10ths. If you don't have a number and a place value, you put a 0. So I'm going to add those together, and I get 7 and 46/100ths. So what we've done so far is the same signs add, and when he says and keep, that means keep the sign. We're going to keep that negative symbol because we're working with two negatives. We don't have any positives in this problem, so our answer is going to have to be negative.
Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact.
Okay, so here's an example of when he says different signs subtract. In this example, we have different signs because we have a positive 4 and 500ths and a negative 12 and 1300ths. So the signs are different. So from 6th grade, when subtracting decimals, we learned to line our decimals up. I'm going to put the 12 and 1300ths on top because if I disregarded the symbols, 12 is bigger than 4. And that's how we set these up in 6th grade. Then, because the signs are different, I'm going to find the difference. I cannot take 5 away from 3, so I have to borrow a tens from the 1. So this becomes 13, and then the 1 becomes a 0. 13 minus 5 is 8, 0 minus 0 is 0, and 12 minus 4 is 8. And I put my decimal lining it up with the other decimals. Then he said in the song, keep the sign of the higher number. What he means by that is, do you have more positives or more negatives? In this example, we have more negatives, so our answer has to be negative. Our negatives outweigh the positives. So you should end up with negative 8 and 800ths. Go ahead and pause the video now and try the next 3 examples on your own.
Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact.
Ah! There he is again. Okay, it's starting to get a little creepy. I might even have nightmares about it tonight. I promise not to play that song again. Let's see how you did. Okay, for this first one, the same signs add and keep. The signs are alike, so I added. And then they're both negative, so my answer would have to be negative. Or if you use a rule, keep the sign of the larger value, that would be the 12. Either way, you'd end up with a negative 17 and 7500ths. For our next one, this is a positive and a negative. So the signs are different. When the signs are different, you find the difference or subtract. And then we have more negatives than positives. We have 15 negatives and 7 positives. So our negatives outweigh the positives. That's why our answer is a negative 7 and 52 hundredths. And finally, the last one, the signs are different, so we find the difference of the two numbers. And in this one, we actually had more positives, so that's why our answer is a positive 4 and 7/10. How'd you do? Let's try adding and subtracting positive and negative fractions now, because fractions are rational numbers. So for this problem, we have 3/8 plus a negative 1/2. Remember from 6th grade, when adding fractions, you find a common denominator. So we need to find the common denominator between 8 and 2. And that's going to be 8 in this situation. So I want to multiply the numerator and denominator by 4. I'm going to rewrite my problem as 3/8 plus a negative 4/8. Then I'm going to apply my patterns of adding integers. I have a positive 3 and a negative 4. The signs are different, so I'm going to find the difference between 4 and 3, which is 1. And then I have a common denominator of 8. Then I ask myself, do I have more positives or more negatives? I have more negatives. I have 4 negatives and 3 positives, so my answer would have to be a negative 1/8. You might see it written with the negative 1 as the numerator, but most likely you're going to see this fraction written as negative 1/8 with that negative sign in front of the fraction. Let's try another one. For this example, I need to find the common denominator first. So ask yourself, what multiples does 5 and 4 have in common? And if you said 20, that's correct. So I need to change negative 2/5 to have a common denominator of 20. So I want to multiply by 4. This becomes negative 8/20. Then my negative 3/4. To get a common denominator of the 20, I'm going to multiply the numerator and denominator by 5. So this fraction becomes negative 15/20. Now I'm going to ask myself the rules of integers. Are my signs alike or different? They're alike. They're both negative. When they're alike, we add. So that would be negative 23, and my common denominator is still the 20. The reason my answer was negative is because I have both negatives. I'm not working with any positives in this situation. So you should end up with negative 23/20. Pause the video again to try 2 examples on your own. Let's see how you did. So we first should have found a common denominator, which was 10 in this first problem. So I changed negative 3/10. It already has a denominator of 10, so I didn't have to do anything to that fraction. And in order to get from 5 to 10, I multiplied by 2 to get negative 4/10. The signs are alike, so I added, and you keep the sign when they're the same because you have both negatives. So your answer has to be negative. And then down here I wrote it with a negative on the outside of our fraction bar. For the next example, the common denominator was 24. So I multiplied this fraction by 4 to get 20/24. And I multiplied this fraction by 3 to get negative 21/24. This is an example when the signs are different, so we should have subtracted. 21 minus 20 is 1. And then you take the sign of the larger number. Well, I have more negatives than positives. I have 21 negatives and 20 positives. So my answer would be a negative 1/24. And then I wrote it down here with a negative in front of the fraction. Hopefully you're saying to yourself, oh yeah, I rock, I got 'em all right. Or maybe you're just sitting there like, is this video over yet? It almost is. We only have one more section. We can't forget about mixed numbers that are also rational. With mixed numbers, the first thing we have to do is change them into improper fractions to make them rational, a quotient of 2 integers. So our first mixed number is negative 1 and 2/5. Remember, to change a mixed number to an improper fraction, we're going to multiply 5 times 1, which is 5, plus 2 is 7. So we're just going to rewrite this as negative 7/5. Our second mixed number, 2 times 2 is 4, plus 1 is 5. So we have negative 5/2. Now we're going to find a common denominator. The common denominator here is 10. So we're going to multiply this fraction by 2, and it becomes negative 14 tenths. And this fraction we're going to multiply by 5, so it becomes negative 25 tenths. And then we're going to ask ourselves, are the signs alike or different? They're alike. Same signs add, so 14 plus 25 is 39. And keep, we're going to keep the sign. We have both negatives, so our answer has to be negative. So you end up with negative 39 tenths. Now it's your turn. You got this. Let's see how you did, champ. Rocky didn't win all those matches without hard work. The first thing you should have done was change these mixed numbers to improper fractions. So negative 3 halves and negative 13 fifths. Then you should have found a common denominator, which was 10. So you change this to negative 15 tenths and negative 26 tenths. The signs are alike, so you add. And because we have both negatives, our answer has to be negative. Same signs add and keep. We kept this negative symbol in our answer. So you should have got negative 41 tenths. For the second problem, when you change them to improper fractions, you should have got 17 eighths and negative 7 fourths. The common denominator was 8. We didn't have to do anything with this first fraction because it already has a denominator of 8. And for this fraction, we had to multiply by 2 to get negative 14 eighths. The signs are different. You have a positive 17 and a negative 14, so you subtract and you keep the sign of the larger number. We have more positives than negatives, so our answer will be a positive 3/8. Finally, let's see how you did on the real-world problems. Because Lucy owes her dad, I used a negative number. However, she received $10 from her grandmother. Received means she has the money, she gets the money. So the signs were different. That's why I found the difference. And I had more positives than negatives. So my answer was a positive. So Lucy would have $6.25 left after she paid her dad back the $3.75 that she owed. And for the last problem, because it said 72 hundredths of a meter down, remember down represents negative, and then climb down another, that's going to be another negative. The signs are alike, so I added, and keep the sign. And the reason we're keeping the sign is because we have both negatives, so our answer would have to be negative. So the decimal that represents the location of the caterpillar would be a negative 2 6/100. But you promised! Sorry, I had to. All right. Good night. See you tomorrow.